Okay, let's take a look at the practice questions from yesterday. Page 571, number 7. Says barium has a work function of 2.48 electron volts. So WO is equal to 2.48, and it's in electron volts. What is the longest wavelength of light that will cause electrons to be emitted for barium? So you're looking, in other words, for the threshold wavelength. So in order to find that, we have to find the threshold frequency. So we know WO equals HFO. So remember, FO is the smallest possible frequency, and so then lambda O is going to be the longest possible wavelength, right? Because C equals F lambda. So if F is the tiniest, then lambda will be the biggest. Okay, so first step, find FO. It's W over H. So 2.48 electron volts over 6.626 to the negative 34 joule seconds. Now, hopefully, before you type this in your calculator, you would take a look at the units and say, oh no, electron volts, joules, that won't work. I need to switch this to joules by conversion factor. 1.602 times 10 to the negative 19 joules per electron volt. Then the electron volts will cancel out. You'll be left with joules on the top, joule seconds on the bottom, which will end up being just seconds, and life as we know it, or 1 over seconds, and life as we know it will be good. Okay, so when you do the math here, you should get 5.996 times 10 to the 14th hertz. So that's your FO. So then lambda O from this equation will equal C over FO. So 2.9979 times 10 to the positive 8 meters per second, and that's divided by 5.996 to the 14th. There's really a 1 there, just didn't look like it hurt. So the top's almost 3, the bottom's almost 6, so that's going to be almost a half. And to the negative 0.5 to the negative 6, so to the negative 5 to the negative 7. If we don't round as much as I just did doing it in my head, it's 4.9998. See, so I didn't round very much. 2 times 10 to the negative 7 meters. Lambda O. All right, that's number 7. Number 8 says, a photocell is used by a photographer to measure the light falling on the subject to be photographed. What should be the work function of the cathode if the photocell is to be sensitive to red light? So if it's sensitive to red light, it means that red light of wavelength 680 nanometers must be the lambda O. Okay, so lambda O must be 680 nanometers. Now, if you look at this little frequency or wavelength chart here, right? So red light is the largest visible wavelength. Remember, largest wavelength will be smallest frequency. So red light will have the smallest frequency. In this question, it's saying if it's sensitive to red light as well as the other colors. Well, red light has the smallest frequency because it has the largest wavelength, which means all of these guys have bigger frequencies. So if it's sensitive to red, if FO is red, then it's going to be sensitive to all the other frequencies because they'll be bigger. So first step, let's find FO. It's equal to C divided by lambda O. Now, I'm hoping you're okay that I just rearranged that in my head. One year I had a student that always rearranged C equals F lambda incorrectly in Science 12.2. Try not to do that. 2.9979 times 10 to the 8th meters per second. 680 times 10 to the negative 7 meters. Not quite as easy to do in my head because everything doesn't quite cancel out as nicely. But you get 4.4087 times 10 to the 14th hertz. Okay, so that's your FO, but the question wants to know what should be the work function. So once you get your FO, then find WO. So equals HFO. So WO equals 6.626 to the negative 34 joules seconds times that 4.4087 to the 14th hertz. Okay, multiply together, and you should get a WO of 2.9212 times 10 to the negative 19 joules. But again, if we go back to the question, it says, oh, it doesn't ask if it's in joules or electron volts. I thought it was going to, what should be the work function of the cathode? Yeah, so it doesn't say it has to be in electron volts, so you can just stop right there. All right, number 9. A threshold frequency of 10 is 1.2 times 10 to the 10 is 1.2 times 10 to the 15th hertz. So in number 9, FO is 1.2 times 10 to the 15th hertz. Okay? What is the threshold wavelength? What is the work function? So for A, lambda O is going to equal C over FO. So 2.9979 times 10 to the 8th, hopefully you got the speed of light down pat now, over 1.2 times 10 to the 15th meters per second and over hertz. So lambda O is going to be 2.49825 times 10 to the negative 7 meters. So that's A. B wants the work function. So WO equals HFO. WO equals 6.626 to the negative 34 joule seconds times, it wants, remember you use F back in the beginning, not what you just found, 1.2 times 10 to the 15th hertz. So WO is going to equal 7.9512 times 10 to the negative 19 joules. That's part B. I think there's a part C as well. Part C says, electromagnetic radiation of 167 nanometers falls on the tin. What is the kinetic energy of the ejected electrons in electron volts? So it's telling us in C then that the lambda of the visible light is 1.67 nanometers. So first step, find the frequency of the visible light, C divided by lambda. 2.9979 times 10 to the 8th meters per second divided by your 167 times 10 to the negative 9 meters. So you get a frequency of the visible light to be 1.795 times 10 to the 15th hertz. Okay? And then it wants EK max. So EK max is equal to HF minus WO. So EK max is equal to 6.626 to the negative 34 joule seconds times our 1.795 to the 15th hertz minus the WO that we found up there, so minus 7.9512 to the negative 19 joules. So we get an EK max of 3.94346 to the negative 19 joules, but they wanted in electron volts. So joules to electron volts, you have to divide by the 1.602 to the negative 19 joules per electron volt, and you end up getting 2.462 electron volts for the EK max, part C. All right, that's number 9. Number 10. We're going to run out of time here in a second, so I'll have to do it on the next video.